angles of a triangle, and specifically throughout this week, we're going to talk about theorems that arise from triangles. So once again, a theorem is something that we can prove in mathematics, something we can show. So for example, the Pythagorean theorem is something you've learned before, like your a squared plus b squared equals c squared. That does involve triangles. We won't talk about that one specifically this week. That is like a theorem. It's something you can show that works for any situation as long as you meet the given requirements. And so throughout this week, we're going to learn about different theorems that are involved with triangles. Whenever we learn about a theorem, we're going to show why it's true, and then we'll be able to use it. So before we use any theorems, we're going to have to show why it works, and then we'll talk about how we can use it and how we can implement it. So we're going to learn about 2 theorems today, and then we'll learn about 3 other ones throughout the week, 2 other ones. I'll have to check my notes again. We'll learn a couple different triangle theorems throughout the week. But today, once again, we're going to focus on triangles for maybe 2, 3, 4 weeks. So it'll be for a little bit that triangles will be a big part of geometry, so we'll focus on them for a little bit. So to start off today, we're jumping into triangles. What are some things you know about triangles? Colton?
They have 3 sides.
They have 3 sides. Awesome. 3 sides. What else? Alex?
3 angles.
3 angles. It's called triangle for a reason. Tri means 3, so we have 3 angles.
What?
I know, I'm just
Whoa, that's crazy. Gage, what do you know?
Add up to equal 180.
Add up to equal 180. Good. That's what we'll talk about today. So all of your angles add to equal 180 degrees. All 3.
Triangles, if you put a bunch of them together, they can make basically.
We can make lots of shapes throughout triangles. We can dissect shapes into triangles. And so if we know a lot about triangles, we can use those to reflect on other shapes we'll learn about in the future. Morgan, what do you have?
Isn't there a lot of different, like a couple different types?
Yeah, well, there's different types of triangles. So we'll talk about today some types of triangles as well, and review some of them. Good. Anything else that we can think about triangles?
They're very pretty to look at.
Okay. One of my favorite shapes.
Triangles make up all of the other shapes.
Yep, so we can build other shapes through them. Good. Pythagorean theorem, that works for right triangles. I'm trying to think what other things we might have learned from past. We'll review there'll be a lot of information we'll talk about that we'll review from previous math classes, but we'll want to remember.
It's a shape.
It's a shape, yeah, good. Thank you, Amanda. All right, so to start off the class, though, we're actually going to talk about this like Gage said. All those 3 angles add up to equal 180 degrees.
They each equal 60.
There's a special type of triangle that can do that, but not every angle of a triangle will always be 60 degrees, because we have right angles in triangles, which is a right triangle, which has 90 degrees. So there are multiple types of triangles. We'll talk about that specifically. But today we're going to figure out why does any angle, or why does all these 3 angles of a triangle have to equal 180 degrees? So that's going to be one of our focuses today.
Why does it? Because like if you draw a circle, the circle goes like all the way around.
So any triangle can be described in a circle. That's something we'll talk about eventually throughout this year. Yeah, that is something we'll talk about. We'll hit that at some point. For right now, though, so I have this triangle on my board, triangle ABC. The triangle ABC has 3 angles, just like it should. So 1, 2, and 3. In order to help us figure out why this equals 180 degrees, we want to show, so our end goal is to show that 1 plus 2 plus 3, all these 3 angles add together equals 180 degrees. That's our end goal. That's where we're trying to end up. We're not going to use any numbers. I don't know any of these angle measures, because I want to make this work for any triangle I have. So in order to make sure it works for any type of triangle, I'm not going to put any angles in there, so I'm not going to put any stipulations on it. They're just random unknown numbers at the moment. In order to help me, I'm going to draw a parallel line to the top of that triangle. So this parallel line is passing through point B, and it's going to be parallel to the base of my triangle. The base of your triangle is always going to be the bottom. Not every triangle will have a bottom part, but whenever you're talking about the bottom part of a triangle, that's going to be your base. And so I have this parallel line that's parallel to my base. So I have my initial 3 angles, 1, 2, and 3. but I get 2 extra angles. Angle 4 is formed by that parallel line in this side of my triangle, and angle 5 is formed by my parallel line in my side of my triangle. So we're going to use all this information to help us figure out the why the 1, 2, and 3 add up to equal 180 degrees. How can we show this is true? And how can we prove that it's a theorem?
Because theorems can't always be
They cannot. Theorems always have to be proven. They're always shown. You can't. Axioms is what we call things that can't be shown. So if something's axiomatic, you just take it as true. So triangles have 3 sides. That's an axiom. You can't prove. They just do. But theorems can be something that we can't prove. So we can prove that 1, 2, and 3 add up to equal 180 degrees. We just have to figure out why. So to start off this, I have angles 4, 2, and 5. What do you know about 4, 2, and 5 together? They're all together going to be supplementary. They're all going to be adding up to 180 degrees. So all 3 of them make a 180 degree angle. It makes that linear angle, that linear pair. All right, so all 3 of them add up to equal 180. So that's one thing we'll want to think about. So we know these 3 equal 180, but that's not what we were looking for. We were looking for 1, 2, and 3 equal 180. So we have to get a little bit more information. What do we know about angle 1 and angle 4?
they're the same.
How do you know they're the same?
Because like every angle on the triangle is
So all 3 of these we're going to say are different angles. We don't know if they're the same or not. We can't make that stipulation. We weren't told that. So I have a parallel line. A parallel line.
oh, so
Oh,
they're
no. Interior.
I have alternate interior angles. Angle 4 is inside my line. It's on the opposite side of my transversal as angle 1. These are alternate interior angles, meaning they're the same. So we know 4, 2, and 5 add up to 180. We know 4 and 1 are alternate interior angles. What can you say about 5 and 3? Are also alternate interior angles. We have our parallel lines once again. We have our transversal that cuts across. So they're alternate interior angles as well. So 4 is congruent to 1, and 5 is congruent to, I should be 3. That's right on. 5 is congruent to 3 because of alternate interior angles. Okay. So we said angle 4, 2, and 5 add up to equal 180 degrees. But 4 is the same as 1, and 5 is the same as 3. So what does that mean about 1, 2, and 3? Not congruent. So 1 is congruent to 4, and 4 is congruent to 5. So if 4 plus 2 plus 5 equals 180, but I said 1 is the same as 4, and 3 is the same as 5, then 1 plus 2 plus 3 equals 5. And so, or yeah, equals 180. Thank you.
Equals 5.
It says it equals 5 equals 6.
I mean 5 is on 180.
So we just showed, without using any numbers, without using any angle measures, we don't know anything about this triangle. So it could work for any triangle. We just showed that it equals 180 degrees. See that? So that's pretty cool. So this works for any triangle you run into. Right triangle, acute triangle, obtuse triangle, left triangle, right triangle, opposite matter. It's any triangle you see. All those interior angles will always add up to equal 180 degrees. Anytime. So this is the theorem that we're going to use, and it's something we'll keep using throughout geometry. Anytime you run into triangles, anytime you're looking for missing angles, anytime you're using those angles, know that they all add up to equal 180 degrees. It's something important that we'll keep using all this year, and you'll probably use it for 2 when you get to trigonometry, beyond for calculus and stuff. So this is important stuff. So that's cool. So that's one of our things we're going to talk about today. Another thing we're going to talk about is different types of triangles. So Morgan, you said there were multiple types of triangles. And so we have three main types of triangles, and then we'll talk about some other three names of triangles as well later on. But these are our three we're going to start with today. So we can name triangles based off of their angles and based off their sides. So if we have a triangle that has three sides that are all unique, all different sides, and three angles that are all unique, this is called a scalene triangle. It will have zero congruent sides. None of those sides are the same. When congruent means equal to each other, congruent means the same. So none of these sides are congruent, none of these sides are equal to each other. So that is a scalene triangle. That's our first type. Our second type of triangle, isosceles. Isosceles triangles have two sides that are the same, and then two congruent sides. Along with this, by having two sides that are the same, they also have two angles that are the same. So this is one of our isosceles triangles. We call these base angles. They're base angles because they touch the base of your triangle. So that's when we give them. No. But if you have no sides that are the same, you'll have no angles that are the same. If you have two sides that are the same, you'll have two angles that are the same. Last one we have, Colt mentioned earlier, is our equilateral triangle. Equilateral triangles have all three sides are the same and all three angles are the same. The only way to get all three angles to be equal to the same number and add up to equal 180 degrees is from all 60. So an equilateral triangle will always have 60 degrees as its angle measures. And all
the isosceles triangle have two of them are 60?
Not necessarily. An isosceles triangle will actually, it won't be 60 because that would make the third one 60, which would make an equilateral. So isosceles triangles will have two angles that are the same, but they could be both 20 degrees, they could be both 30 degrees, they could be both 45 degrees. It doesn't matter as long as they're under that 180 degree limit of the curve. Oh, yeah.
So you don't have to add up all this, like, two.
No. So all three angles will add up to equal 180, but these two together don't have to equal anything. They just have to be equal to each other. So these are our three types of triangles we're going to talk about. These will be some names we'll keep using. And these triangles have some special properties depending on what they are. Scalene isn't really anything special just because it's all different. But isosceles, there's some special things about isosceles triangles we'll talk about that will be important later on. So I have three triangles on this board. I want you to find your missing angle. So each of them are missing an angle. They only have two angles in each of them. So find your missing angle and then figure out, is this isosceles, is this scalene, or is this equilateral? So before you get started, how can you go about finding that missing angle?
All three of them are the same. And then whatever's left.
What do you mean whatever is left?
But the add that. Like 16, 16, like one. What the bunch of saying. Anyone from that else can add up to one of these.
So good. So you always make sure that all three of these angles add up to equal 180. So in order to find that missing angle, just subtract your 2 from 180, and then whatever's left over will be. So take a moment, see if you can find both all three of those missing angles, and see if you can put a label on what the triangle equals. Okay, so looking at this first triangle. Oh, I didn't pick this up. Pick this up again. I didn't do that. All right, looking at that first triangle. What did we find for the angle measure?
60 degrees.
60. So 60 plus 60 plus 60 equals 180. So your missing angle was 60. What does that make for that triangle then?
Equilateral.
Equilateral. Next, so we have an equilateral triangle for our first one. What about for our second triangle? What did we find? 64. Okay. What does that mean for this triangle?
Isosceles.
Isosceles. So isosceles. That's not spelled right. Last one. 95. What does that mean about this triangle? It's scaling. None of those angles are the same. Awesome job. So we have equilateral, isosceles, and scaling. So once again, 3 sides, 3 angles are the same. 2 sides, 2 angles. No sides, no angles are the same.
I want to use colors.
What?
I want to use colors.
I want to use colors.
Yeah, like different colors. Like how you use blue, red, and purple.
You're welcome.
Yeah.
All right, so we talked about scaling, isosceles, and equilateral, but we also have a couple other names we can name triangles that also is sometimes important to know. So these are our right triangles, obtuse triangles, and acute triangles. So once again, right, obtuse, and acute, these are words we use in the beginning. You're describing angles. If you had a right angle is 90 degrees. Obtuse angles were greater than 90 degrees. Acute angles were less than 90. So depending on what angles show up in your triangle, we can also name them based off of that. So a right triangle has one angle that's equal to 90 degrees. It's impossible for a triangle to have 2 angles that equal 90 degrees because you would have to have a third angle as well, but 90 plus whatever extra would already be greater than 100 degrees. So you can only have one right angle in a right triangle at a time, or in any triangle at a time. So they're a right triangle. Obtuse triangles, you have one angle that's obtuse, and the other 2 are acute. So one angle is greater than 90 degrees, your other 2 are less than 90 degrees. But remember, all 3 of them have to add up to equal 180. So you can only have one obtuse angle. Same thing with the right triangle. Last one, acute. If none of your angles are right and none of them are obtuse, that means they're all less than 180, or they're less than 90 degrees. That means all 3 angles are acute. You have an acute triangle. So right triangles, you have your right angle. Obtuse, you have your wide, fat, obtuse angle. And then acute, you have all your small, so acute. We okay with this? Stuff we've heard before from whenever you were in this 7th, 5th, 4th grade. Geometry. All right, so we talked about some different types of triangles. We talked about how they all add up to equal 180. We're going to talk about one other theorem today, and that's called the exterior angle theorem. But before we talk about the exterior angle theorem, let's talk about what an exterior angle is and how we can figure out what this is. So we have this angle 1 here. So angle 1 is an exterior angle. The way you get an exterior angle is you take one side of your triangle and you extend it out and you keep pulling it out. And so that side length and that extended side then make an angle on the outside of your triangle. So any angle on the outside is an exterior angle. Any angle on the inside of your triangle is an interior angle. Using those exterior, interior words again. So our goal is to figure out what is the angle measure of 1, and then how will we use this to figure out what the exterior angle theorem is. Make some observations. So what can we find based off of this image? What can we figure out? So 140 or 41 and 90 or 89. What are those add up to? 130. Okay. How can that help us? Can you figure that third angle? Our missing angle of our triangle? So this will be an acute triangle because all of these will be less than 90 degrees. Well, what's that third angle going to be? So 130 plus 50 will give us 180. So we know 50 will be that last angle. Okay. Based on this information, can I figure out what angle 1 is? How do you know? Because what?
It is.
It is? Okay. What is this? What do we call these two? They're supplementary. They're a linear pair. They make a line. They make a 180-degree angle together. And so 50 plus 130 is a 180-degree angle. Good. So we know angle 1 is 130 degrees. That's what we were looking for to start off with. What do you notice about angle 1 compared to our other two given angles?
Flip side.
Okay. It's bigger than each of them. Amanda, what did you notice about those two blue angles to start off with?
Close to the.
What else? What did you tell? What was the first thing you made me write down? What do they add up to?
130.
What's our angle 1?
130.
130. Oh, wait, what's going on here?
I don't know.
So our exterior angle
It's the same as both of the two interior added up.
Good. That's our exterior angle theorem. So our exterior angle theorem is any exterior angle will always be equal to those opposite interior angles. So your two opposite angles that aren't touching your exterior angle, add them together, that's always your exterior angle. It'll work for any triangle once again, because any three angles at our angle 180, and then we can use that to equal with your something. Okay. So no matter what, this will work for any type of triangle, any type of angle you have. That's our exterior angle theorem. That's something that's important to know. It's helpful for solving for missing angles. It's helpful for solving for sides of triangles, or if you have triangles next to each other, it's helpful for solving angles in that. So we'll see this show up later on throughout the year. Look at some problems. So we can do this. So we have two problems on here. We're going to look at the first one together. And we'll talk about how we can solve this, and then we'll do the second one together as well. All right. So I have a triangle. I have angle x and angle 48, or x degrees and 48 degrees. Those are two of my interior angles. I have 2x minus 17 is the measure of my outside angle. I want to figure out what all of the angles of this triangle are. So I need to first, in order to figure out what the angles are, I need to solve for x. What did we just learn with the exterior angle theorem?
The outside is always equal to the inside plus the other one, but we don't have the other one.
Well, your exterior angle will always be equal to your opposite two angles added together. So we have all the information we need. We just have to write it down. So I know my exterior angle, 2x minus 17, equals my other two added together. So x plus 48. I just take both of those two expressions, set them equal to each other, and that's equal to my exterior. And from here to solve, we just need to get x by itself. So I have x on both sides. So which side do you want to get it on? Left or right? Left. Okay, we'll go with left. So I'm going to subtract x, because right now it's a positive number. They're being added, so I'll subtract it. So 2x minus 1x, that gives me just a single x left over. So x minus 17, that cancels out, this equals 48. Get x by itself, I just need to add that 17 over, inverse my constant. So I have x equals 48 plus 17 is 65. So x equals 65 degrees. So we scroll back up top. Now that we know x equals 65, sorry, you're a big line. Are you okay? All right, so we know x equals 65. In order to solve this, solve what those missing angles are, we can plug x back in. So x, we said it was 65, we know this angle is 65. We know your exterior angles are both of these two angles added up, so I can either plug 65 in for this and solve it, or simplify it, or I can figure out what's 65 plus 48, and that gives me 113 is my other angle. If I want to figure out my last angle, I would just have to do 180 minus 113, which leaves me with 67 degrees. And we solve for all of our missing angles using our exterior angle theorem. Are we okay with that? All right. So I have this other crazy situation over here. So I have two triangles that are sort of formed together. They touch at a point. And I'm only told three things. I'm told this bottom angle is 40. I'm told this is a right angle. And this is a right angle. And then I have 8 other missing angles on these triangles. Our goal is to figure out what the measure of every one of those angles are. All 8 of them.
Well, are they symmetrical?
Symmetrical.
Symmetrical.
I don't know.
Because then if we just write out the one with 40, and then it's the same as it goes. Oh,
But we don't know what they're symmetrical or not. So let's start with angle 1. How can we figure out the measure of angle 1?
So right angle, isn't that like 90 degrees?
So this is 90, good.
No.
What's this?
40.
So added together equal
130.
130. How much?
150.
Use 50 left. Okay.
So 3 is 50. Say 50.
So why is 350?
Because it's it's one of the things that we had. It's vertical.
Vertical angles. So they're across from each other on these intersections. So these are vertical angles. Can you figure out what 2 is? How do you know it's 130?
Honestly.
So these 2 are supplementary. They're right next to each other in a needle line. So that means it's 130. What does that mean for?
130.
130 as well. More vertical angles or linear angles. Okay. Can I figure out 5?
Yes. 40.
How do you know?
Because it's a point. So yeah, it's just like congruency 40.
How do we know they're congruent?
Because it's not one of them.
Do we know these are exact same?
Yeah, I mean,
So let's think.
vertical.
This is 50. This is 90. Add together, we equal 140. 180 minus 140 leaves us with 40. So they happen to be the same, but we didn't know that heading into it. You can't just assume that, remember? We can't just assume by the picture. It might look right, but we can't just assume. We have to prove it, show it, show the math. What about 6?
Yeah. 90.
Angle 6?
It's 90.
So it's an exterior angle.
It's not. It's what's.
So exterior angles are both of your opposite interior angles added together. So 50 plus 90 is
140.
140. So that's 6. We have 7 way up here. What's 7? 90 as well. You could think it's an exterior angle to both of these 2. So it's 90. Or you can think they're supplementary to our right angle. So any angle that's supplementary to a right angle is also 90 degrees as well. Last one, 8.
40.
Just 40?
140.
140.
Oh.
You can figure out by exterior
Yeah.
angles, or you can think 40 plus what equals 180, so 140. And so you found all of those missing angles with just that little piece of information. Just like 3 pieces of information, you found all of that. So that's pretty cool. It is so cool. Isn't math amazing? Like, you can solve so much with just little things. As soon as like you learn something, great. Everyone should love that. All right, so just sort of recap all the things we talked about today. So we talked about all your other angles adding up to equal 180 degrees in your triangle. We talked about different names of triangles: your equilateral, your isosceles, your scalene, your right, your obtuse, your acute. We talked about the exterior angle theorem. So that outside angle always is equal to the other 2 added together. A student in my other class saw this made EAT if you do exterior angle theorem. So if you want to abbreviate why you're doing something, you write EAT for using the exterior angle theorem. So he thought it was pretty good.
You thought of it?
Mason stuck. All right, so I'm going to leave you with this. So you have 3 expressions on this triangle. You have 2x plus 14, 3x, a missing angle we don't know, and 4x minus or plus 39. So your goal is to solve for x and then find all of the missing angles. So use that exterior angle theorem. Your outside angle equals your other 2 added together. So see if you can set that up and see if you can solve. That's where we'll stop for today.
What